All right, welcome everybody. Okay, so today we're going to be calculating pi. Pi is kind of an interesting number. Um, Last chapter we talked about straight sided shapes, polygons. This time we're going to be talking about curved lines. And how do we deal with curved lines? Well, it's really hard to tell how far around a circle is because it's not straight lines. So how do you measure something that's not a straight line? Straight lines, rulers, curved lines, there really isn't a tool for that. So we use some math, and we can figure out what is called the circumference, the distance around a circle. And we can use this to kind of figure out what is pi. All right, so here's a little bit of vocabulary. Step one, distance around a circle, circumference. The center of a circle is called the center point, duh, and diameter is the distance all the way across a circle, where a line goes all the way across a circle and through the center point. All right, let's see what we're going to be talking about here. So to find pi, all you have to do is take the circumference and divide it by the diameter. But once again, how do you get the circumference? Well, here we go. Let's take a circle. How do we figure out what is the circumference? Well, one thing I do know is that it's smaller than the square, and I can measure the square. And if I take another square and put it on the inside, I know that the circumference is larger than the red square. So it's smaller than the blue square, larger than the red square. Watch what we can do. So if I were to measure this, let's say that this was 35 millimeters and that this was 24 millimeters. Whoop. All right, let me do this. Okay. Here we go. All right, and this is 25 millimeters. Now think about it. If this was 35 millimeters, if I want to know the perimeter of the entire square, that would be 140. 35 times 4. Then when I slid the line in, that meant that the diameter of the circle would also be 35 millimeters. Get it? Now with the smaller one, since this is going to be 25 millimeters, we multiply that by 4, and you end up getting 100 millimeters. So I do know that the circumference is going to be larger than 100 millimeters, yet smaller than 140. All right, so here we go. In order to find pi, you have to do the circumference divided by the diameter. So if we think about the square, the distance around the square is 140, that's the large perimeter, and I divide it by the diameter, which is also 35. So 140 gets me 4 over 1. When I do 100 over 35, I divide by 5 and divide by 5, and I end up getting 20 over 7. Now in order to find out what the circle is, I have to find out what the average is between these, because the average would be somewhere in between the big and the little. And when I take the average, I add these together, common denominator, and divide by 2. And that gets me 24 over 7, which is 3.43, about. And think about it, we're already pretty close. We all know pi is 3.14 something something something. Now we're already at 3.43. So, not a very good guess, but close. How do I make it a better guess? Well, since a square has 4 sides, what if I go with a pentagon? Excuse me, a hexagon. And 6 sides. And I measure the side. Let's say the side is 20 millimeters. Multiply that by 6 because there's 6 sides, and that gets me 120 millimeters for the large perimeter. The diameter is still 35 because it's the exact same circle. And then when we measure the small one, it's 18 millimeters. Multiply it by 6, I get 108. So now we know that we are in between the large perimeter divided by the diameter, which is 24 over 7, and 108 over 35. To find the average, add them together. Get a common denominator, and use a calculator to figure this one out. 114 divided by 35, 32.57. Notice we're getting closer to 3.14, and the reason we're getting closer is because the amount of space in between the small and the large shape is getting smaller. You guessed it, let's go with an octagon. 8 sides. So if I measure it, I end up getting 15 millimeters times 8, because there's 8 sides. Diameter is still 35, and 13 millimeters on the small one. And I get 104. So here we go. I get 24 over 7 again. and I get 104 over 35. Common denominator, to find the average, divide by 2, I get 112 over 35, which is surprisingly a nice neat number, 3.2. Notice we're getting closer to 3.14. All right, last one, I promise. Here's a decagon. Notice the amount of space we've got here. Not very much between the small and the little shape. It was actually kind of tough to do on the computer. All right, so this one's going to be 11 millimeters times 10, which gets me 110. But technically it was about 11.3 when I did it, but I rounded down to 11 millimeters, which kind of makes it interesting because the smaller one's also 11 millimeters. It really wasn't. It was about 10.7, but once again I rounded up. The neat part here is I'm going to get 22 sevenths, and of course, the other one would be exactly 22 sevenths also. When I add them together, I get 44 sevenths, I divide by 2, and yeah, I get 22 sevenths. And 22 divided by 7, 3.14. It has a few more decimals, but yeah, 3.14. Now, if we wanted to make this even closer, well, we could go into 12 sides, 20 sides, and if you were Pythagoras back about 3,000 to 5,000 years ago, forget exactly how long, he actually did it with 112 sides on the small shape and on the other shape. All right, so I hope this helps explain what you've done in class. If you got any questions, don't be afraid to ask your teacher. See you guys later.